Tonight, we're going to explore how humanity can still be alive today, and yet already belong to the extinct past of most life that may ever exist. The universe is 13.8 billion years old. That sounds unimaginably ancient, old enough for stars, planets, and perhaps civilizations to have appeared long before Earth. It is why we picture ourselves as latecomers in a galaxy that should already be crowded with history. But by the clock of the longest-lived stars, the universe has barely begun. Small red stars can continue shining for trillions of years, long after the sun is gone. One theoretical estimate found that when our solar system was born, only about 8% of the potentially habitable planets that will ever exist had formed. The other 92% still lay in the future. That means most life may not be behind us. It may be unimaginably far ahead. Civilizations born around those future worlds could look back toward the beginning of cosmic history and find Earth already silent. Our oceans gone, our cities erased, humanity known, if it is known at all, only through traces left by one of the universe's earliest technological species. From their perspective, we would not be the young civilization searching for ancient aliens. We would be the ancient aliens. By the end of tonight, you're going to understand why life like ours emerged so early, why most potentially habitable worlds may still be unborn, and why humanity could become extinct before the great majority of cosmic history has even happened. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. To understand how a universe this old can still be young, begin with the stars that use their fuel most slowly. Our sun burns brightly, consuming the hydrogen in its core quickly enough that its entire stable lifetime will last only around 10 billion years. Smaller red stars behave differently. They are dimmer, cooler, and extraordinarily efficient, drawing on their fuel so gradually that some could continue shining for trillions of years. Somewhere in the galaxy, one of those stars is burning right now. It may already be older than Earth, yet it has consumed only a small fraction of the fuel available to it. Long after the sun has swollen, died, and left the solar system dark, stars like this could remain almost unchanged. The distant universe will therefore not simply be the universe we know today, stretched across more time. Bright stars like the sun will become rarer. The night will grow darker. But around the smallest surviving stars, planets could still remain warm enough for oceans, chemistry, and perhaps biology. Worlds born in that future would emerge into a cosmos where Earth belongs to the deep past. Their inhabitants might study our era the way we study the earliest chapters of life on our own planet, indirectly through faint traces left behind across impossible spans of time. The scale of that future is almost impossible to hold in the human mind. Everything that has happened so far, the first stars, the formation of galaxies, the birth of Earth, every species that has lived here, and every civilization humans have built, would occupy only the opening moments of the universe's full story. Sit with that for a moment. An opening minute, not an hour, not a single day, a minute. Everything we have ever done, everything anyone has ever built or lost, fits inside that 1 minute, with the rest of the stretch still dark and unlived ahead of it. We tend to think of ourselves as latecomers. We picture the galaxy the way we picture an old, crowded city, one that was already full of history long before we arrived to look at it. Somewhere out there, we assume civilizations rose, built things, learned things, and vanished again, over and over, for millions of years while we were still learning to stand upright and strike stone against stone. Every old legend about visitors from the sky, every whispered story about ancient ones who came before, carries the same hidden assumption. It assumes there was a long line of others standing in front of us, and that if we just look back far enough, we will eventually find them. So when we go looking for whoever came before us, we look backward. We search our own past, in old stories and old stone, for traces of elders who must have arrived first. We dig, we translate, we squint at ruins, hoping the ancient ones left something behind for us to find. We look over our shoulder because that is where we assume they are standing. Somewhere behind us, deeper in time, further back than we have thought to search. It is not a strange assumption to make. The universe feels old to us because everything about it dwarfs a human life. A single century already feels like more time than we can hold in our heads at once. Multiply that by tens of millions and the number stops meaning anything at all. It just becomes a synonym for forever. So we assume forever has already been running for a very long while, and that whatever forever contains, it must contain plenty of others who arrived before we did. But here's where it gets strange. The evidence points the other way entirely. Not old, almost newborn. We are early, not late, earlier than we have ever been willing to imagine. The universe is not the ancient, settled place we picture when we imagine it. It is not carrying millions of years of accumulated history behind it, quietly waiting for us to catch up. By the numbers we actually have, we did not arrive at the tail end of some long cosmic story that had already been running for ages before we showed up. We arrived close to the very beginning of it, closer to the start than almost anything that will ever exist. It is a strange thing to have to relearn, that the story we thought we were reading from somewhere near its final chapters turns out to be a story we are reading from its very first page, with almost the whole of it still unwritten. That flips a question we almost never think to ask. We ask whether there is anyone else out there. We rarely ask when they would be. If someone, somewhere, is eventually going to be the ancient ones, the impossibly early arrivals who were already here before almost everyone else, what if that is not some other civilization out among the stars? What if that is us? Not confirmed. Not yet. Only asked. Held open the way a question should be held before it has earned an answer, without rushing to settle it before we have looked at what is actually there. That question is what this hour sits with, turning it over slowly, the way you might turn over a stone to see what is written on the other side. Why life could not have started much earlier than it did, given everything that first had to happen just to make it possible. Why the overwhelming majority of all the worlds that will ever exist across the whole life of the universe have not been born yet. Not even close, not by a wide margin. Why the age of life in this universe is barely starting, with trillions of years still stretching out ahead of it. So much time ahead that everything behind us shrinks to almost nothing by comparison. And why that single fact, that we are early rather than late, quietly takes the oldest idea we have ever told ourselves about ancient aliens and turns it all the way around, until it is no longer pointing out at the stars. It is pointing back at us. None of that is settled yet. It is only a question, held open, the way the red star holds its fuel, patient, unspent, waiting for a future almost too long to picture, a future that will still be unfolding long after every trace of us is gone. But it is where this has to begin. Not with an old universe full of elders we somehow missed on our way through, but with a young one, still filling in its first pages, still deciding what it is going to become. And us, somehow, standing closer to the front of that story than we have ever let ourselves believe. Closer to the beginning than to anything we would recognize as an ending. Here is the number that is supposed to settle it. 13.8 billion years. That is how long the universe has existed. Start to now, and on its own, it sounds like an unanswerable age. The Earth, at 4.5 billion years old, has only been here for the last third of that stretch. A late arrival, even by the universe's own accounting. 13.8 billion feels like the far end of something. A number heavy enough to close a case. A universe well into its life. A species arriving after most of the story has already played out. It is not. Not if you measure by the right clock. Ours has always been human years, birthdays, centuries, the span of a single life. The universe runs on a different one, the lifetime of the stars themselves, and by that clock, the case is not closed at all. It is barely open. Swap the clock and the number stops meaning what it used to mean. 13.8 billion years is not a measure of how far along the universe is. It is a measure of how far along we happen to be standing, which is a different question entirely, and one with a much stranger answer. We do not stand somewhere in the run of the story. We stand right at the front of it. Think about what that clock actually looks like. Astronomers map the far future in long stretches they call eras, each one defined by what the universe is doing at the time. The stretch we happen to live in has a name. They call it the stelliferous era, the age of shining stars, the great span in which the universe is full of galaxies and starlight, and worlds warmed by suns. It began a few 100 million years after the beginning, when the first stars lit for the first time, gas collapsing into fire in the dark where there had been no light at all. Before that, there was no starlight anywhere, not a single point of it, in the whole of the young universe. It does not end soon. On the best current reckoning, it runs until somewhere around 100 trillion years from now, when the last stars finish forming, and the final faintest ones burn down and go dark for good. Set the two numbers side by side. 13.8 billion years have passed. 100 trillion is how long the whole age of starlight lasts. Divide the first number by the second and you get something so small, it barely deserves a decimal point. Not 1%. Not 1/10 of 1%. Closer to 1 part in 7,000. Not a fraction anyone would bother writing down. A rounding error. We are not standing in the middle of the story. We are not standing near the end of it either. We are standing in the first sentence. The opening minutes of an age built to run for trillions of years, with almost the entire thing, nearly all of it, still ahead, unwritten, unlived. Here is a way to hold that number that actually fits in the mind. Take the whole age of shining stars, the full 100 trillion years of it, and compress it down into a single calendar year. Squeeze the entire thing into January through December. Now, find us on that calendar. We do not even make it to breakfast. Everything that has happened since the universe began, the first galaxies pulling themselves together out of gas and gravity, the birth of the sun, the 4 billion years it took life on Earth to crawl from a single cell to something that could ask questions about its own beginning. All of it, the whole run of cosmic history so far, fits inside the first morning of January the 1st. The sun itself would not have formed yet. It would not exist until the small hours of that first day, long before sunrise. Everything we are in the habit of calling ancient, the dinosaurs, the oldest rock, the oldest light any telescope has ever caught, would be over and done before the first dawn had properly broken. Push a little further into that same morning, and every human civilization that has ever risen, every pyramid, every empire, every war, would already be finished, folded into the minutes just before sunrise, gone before most of the world had woken up. 364 days would still be sitting ahead of us on that calendar, unopened. Most of them not holding a single star or world or living thing we would recognize. Not because nothing is coming, because almost nothing has happened yet. The calendar is not describing an old, tired universe coasting toward its close. It is describing one still waiting for its year to properly start. That is the actual shape of where we stand. Not late, not even early in the small, casual sense of the word. We are early in a way that barely has a name for itself. Present for the first working hours of something built to run for trillions of years, with the calendar's own year barely turned past its first page. And the clock we just swapped in, the lifetime of stars rather than the lifetime of a person, is the clock everything else in this hour is going to run on. Hold on to it, because the next question it raises is an uncomfortable one. It starts close to home. The sun feels like a reasonable measure of how long a star can last. It has been burning for 4.5 billion years already, and it has years left in it still, a life that sounds long and settled by any human accounting. 10 billion years, birth to death, is not a small number. It reads like the definition of permanence. That feeling turns out to be exactly backward. The sun is not a slow, patient timekeeper we can use to measure the age of stars in general. It is one of the fast ones, and what actually sets the length of the age we are living through has almost nothing to do with a star like ours at all. It has to do with a far dimmer, far more patient kind of star, one that has barely started spending what it was given. That dimmer, more patient star is not the strange one. It is the rule. The sun is the exception, and a poor one to be building a whole timescale around. Here is why. A star that burns bright burns fast. That is not a metaphor, it is how fusion works. More fuel consumed every second to throw off more light every second. And the sun, warm and reliable as it feels from where we stand, belongs to that fast, hungry crowd. 4.5 billion years burned already. Roughly 5 billion left before the hydrogen runs thin, and then the ending starts. The star swells outward first, ballooning into a red giant, far larger than it is now, large enough to swallow the inner planets whole. Then it sheds its outer layers into space in slow, drifting shells of gas, and what remains settles into a small, dense ember that will spend the rest of forever quietly cooling in the dark. 10 billion years, birth to death, start to finish. That is the sun's whole run. Not slow, not patient, fast, hungry, short, measured against the clock that actually decides how long the age of starlight runs. So, the sun is not the yardstick. It never was. It is one of the casualties, a spark near the start of a fire built to burn for trillions of years, already most of the way through its own brief turn before that fire has properly caught. The stars that set the real length of the stelliferous era look nothing like it. They are small, dim, and red, faint enough to go unnoticed in a sky crowded with brighter neighbours, and they do not burn so much as sip, spending their fuel so slowly that a single one of them will still be shining when 1,000 suns have already lived and died. Stars like ours will rise and burn out, generation after generation, many times over, before the age of starlight is even half spent. A star that patient does not announce itself. It does not flare. It does not swell into anything dramatic. It does not beg to be noticed from across a galaxy. It simply keeps burning, quietly, at a rate so careful it barely counts as spending fuel at all, for longer than almost anything else in the sky will last. Wait, if almost none of this can be checked against a clock we can actually watch run down, what are we really standing on? That question deserves a straight answer. None of this is something anyone has watched happen. Nobody has sat and observed a small red star burn for 1 trillion years, let alone 10. Everything about the far future, the sun's ending, the age of starlight's end, the vast stretch of dark that follows, all of it is calculation, not observation. We trust the calculation because we understand, from the physics we can test here and now, how slowly a small dim star fuses its hydrogen. And because we can point telescopes at galaxies and measure how much star-making gas is left, and watch that supply running steadily lower. But underneath the calculation sits an assumption. It assumes the rules governing stars and fuel and light hold steady across a stretch of time even longer than the universe has existed so far. That is a reasonable assumption. It is how physics has always worked, everywhere we have ever been able to check it. It is not the same thing as having been there to see it happen. We do not know for certain that the rules will hold across 1 trillion years, only that nothing we have ever measured suggests they will not. Call the far future what it actually is, the best answer the physics gives us, not a fact anyone has witnessed. But here's where it gets strange. Even granting all of that, even taking the projection entirely at its word, the age of starlight itself turns out to be small. After the last of the small red stars finally goes dark, the universe does not stop. It moves into a stretch astronomers call the degenerate era, a name for cooling corpses, the collapsed remains of dead stars, white dwarfs and neutron stars, drifting on through the dark for a length of time so long it has to be written with dozens of zeros, a number that makes trillions look small. After that comes an age that belongs to black holes, the last structures left standing, slowly leaking their mass away into nothing over a span that makes even the degenerate era look brief by comparison. No fire left anywhere by then. No warmth, just the slow evaporation of the last dense dark remnants, one particle at a time, into an emptiness with nothing else in it. Not the whole story, not even most of it. A thin, bright band of stars and warmth and worlds, and then dark, and then darker still, for longer than any of it lasted in the first place, by a margin too wide to hold in the mind. Everything we have ever meant by light, every world it has ever warmed, every living thing it has ever grown, belongs to a sliver near the very front of a future that spends almost the whole of itself with no star left burning anywhere inside it. That sliver is where every event we have ever called ancient actually sits. The oldest light any telescope has caught. The oldest rock ever dated. The first living cell to divide. All of it crowded into the very opening of the story. Not because little else has happened since, but because little else has had the time to happen yet. 13.8 billion years feels like an age only because it dwarfs a human life past any comfortable comparison. And a mind built to measure decades has no honest way to picture a trillion. So it rounds the whole thing up to forever and stops looking closer. Measured against the clock, the universe actually runs on. It is not late, and it is not even the middle. It is the first tick. The spark has barely caught. The fire built to burn for trillions of years has barely started. And everything we have ever called history so far is only the first flicker of it catching light. And a universe that has only ticked once is nowhere close to finish making itself. You do not have to take that on faith. Look up on a clear night, away from any city glow, and the unfinished work is still visible, still happening, right there above you, if you know what you're looking at. Whole galaxies are colliding, not once long ago in some closed chapter of history, but continuously, all across the sky, in slow motion crashes that take hundreds of millions of years to finish falling into each other. Streams of stars get pulled loose and stretched into long tidal arms. Two separate spinning disks slowly lose their shape and tangle into one. Our own galaxy is caught in exactly this kind of collision course, drawn toward its nearest large neighbor a little further with every passing age. And in a few billion years, the two will merge into something larger than either one alone. That merger has not happened yet. It is still ahead of us. One more piece of construction the universe has not gotten around to finishing. And inside our galaxy, right now, new stars are being lit. Clouds of gas and dust drift through the spiral arms for long stretches doing nothing at all, then collapse under their own weight and catch fire, opening nurseries that glow faintly across the galactic disk, and cool again once the youngest, brightest stars inside them have finished carving the cloud apart. Some of those clouds are lit up right now by stars that did not exist a few million years ago. An eye blink on any clock that matters here. This is not a memory of something the universe used to do, back when it was busier than it is now. It is happening tonight, in real time, somewhere in the dark over your head, while you sleep. A universe settling into old age would not look like this. It would look finished, still, done, in the way a house is done once the last coat of paint has dried. Not finished, not settled, still colliding, still igniting, still rearranging its largest pieces on the grandest scale it has. A place under construction, with most of the buildings still ahead of it. And we happen to be here for the early part of that work, watching a structure go up that will not be complete for longer than any of us can really picture. So why does none of this feel young? Why does 13.8 billion years sit in the mind like something impossibly old, ancient beyond argument, a number heavy enough to close the case before it has even opened? Because we have nothing honest to measure it against. Recorded human history runs to a few thousand years, a handful of harvests and dynasties and wars stacked end to end. Every civilization that has ever risen and fallen, start to finish, fits inside something like 10,000 years. Even our own species, counted all the way back to whatever first stood upright and called itself something, is only a couple 100,000 years old. Every grandparent anyone has ever had, every language ever spoken, every fire anyone ever built to keep warm through a long night, all of it sits inside that same short stretch, set 13.8 billion years next to numbers that small, and the mind simply has no working shelf to put it on. It has nothing in its own experience even distantly the right size, so it rounds the whole thing up to forever, files it away, and stops looking any closer. But the universe was never running on that clock. It runs on the clock of stars, and measured against that clock, 13.8 billion years is not old at all. The dim, patient stars that will end up deciding how long the age of life actually lasts measure their own lives in trillions of years. The dark stretches that follow them run longer still, spans that need dozens of zeros just to write down. Set against a scale like that, this present moment dwarfs a human life completely, and still counts as early. We call this moment old because it dwarfs us. It does, but dwarfing us is not the same thing as dwarfing the universe. And that is the mistake sitting underneath almost every gut feeling we carry about deep time. The quiet assumption that whatever outlasts a human life must also be near the end of its own. A candle burning for an hour looks impressive standing next to a match. It looks like almost nothing standing next to a star. 13.8 billion years is the match held up against everything we have ever personally known, and it is the candle held up against what the dim stars have left to burn. The number does not change, only what it is being compared to does, and we have spent our whole existence comparing it to the wrong thing, by the only clock that actually decides how this story runs, the stellar one. This is still the first hour, and we are early risers in it, awake while most of the house around us is still going up, walking through rooms that have not finished being built, past scaffolding that will still be standing long after everyone listening tonight is gone. That word, early, is about to mean something far more specific than it has so far. Specific enough to answer a question nobody has asked you plainly yet. If the universe has barely begun, with almost the whole of its history still ahead, where does that put the Earth? Not in space, in time. Among every world that will ever exist, did we arrive somewhere in the middle of the crowd? Or somewhere stranger? Here is the number. When the Earth formed, about 4.5 billion years ago, only around 8% of all the habitable worlds the universe will ever make had been born yet. The other 92% were still ahead of us. Still unbuilt. Still waiting on stars that are not yet lit. 8% had arrived. 92% had not. Earth walked in first. Earth is not a middle child in the family of worlds. It is one of the firstborn. Almost all of its siblings have not arrived yet. That figure comes from laying two separate pictures on top of each other. The first is the star formation history of the universe itself. Read directly out of the sky. Looking far out into space is looking far back in time. So light from the most distant galaxies shows the universe young and busy, still furiously making stars, while light from nearer galaxies shows that same activity slowing down and settling. Gather enough of that light across enough distances, and you are not just looking at a scatter of galaxies anymore. You are looking at a timeline. It shows exactly how the rate of star birth rose and fell across the whole of cosmic history. The way a tide leaves its height marked on a wall long after the water is gone. The second picture is planetary, built out of a different kind of patience. Years spent watching stars for the telltale dimming and wobble of worlds crossing in front of them and tugging at them from orbit. From that comes an understanding of how planets form, how common small rocky ones turn out to be, and what kind of stars tend to host them. Lay the planet-making picture over the star-making one, run the combination forward and backward through time, and what falls out is a full timeline, a history and a forecast of every habitable world the universe will ever produce. Two researchers ran exactly that calculation. The answer was stark. At the moment Earth appeared, the universe had built only a sliver of the rocky, potentially living worlds it is ultimately going to build. 92% of all habitable worlds are still ahead of us. They are not sitting out there now, unnoticed, waiting to be found. The gas that will eventually become them is still drifting uncollected, inside galaxies that have not yet folded themselves into stars and planets at all. Most of it will end up in places we cannot see the far side of yet. Dwarf galaxies that sip their gas slowly. Galaxy clusters holding reserves that will not finish collapsing for trillions of years. Earth arrived into a universe that had barely begun building anything. And yet the early fraction alone is not small. Within the observable universe right now, worlds broadly like Earth number somewhere on the order of 10 to the 20th power, a 1 followed by 20 zeros. Visit one a second, and you would not finish counting them in the entire current age of the universe. That staggering number is only the 8%. The universe is on track to make many times more, the great bulk of them in an era none of us will live to see. Here is what that does to the old idea of ancient aliens, the picture of elders who have been out there since long before us. It rests on a hidden assumption that worlds like ours have been forming for an immense stretch of time already, that somewhere behind us lies a long corridor of cosmic history, thick with Earths that rose and fell, plenty of time and plenty of places for something older than us to get a head start. The planet-making history says the opposite. There was no long corridor. We came near the front of the line. Walk backward from this moment, and worlds thin out fast. Fewer stars, fewer planets, fewer chances. Go back far enough, and there is essentially nothing like Earth at all. This is a projection, not a measurement, and it deserves to be treated as one. The 8% comes from a model, built on the assumption that star formation keeps behaving the way our current picture says it will. Nudge those assumptions, and the number moves. It might turn out that 85% of habitable worlds still lie ahead. It might be 95. How common habitable worlds really are is itself uncertain by something like a factor of a few, and that uncertainty runs straight through the final figure. Change the inputs however you like within reason, and one thing refuses to move. Earth formed early. The majority of habitable worlds lie in the future. We are nearer the beginning of planet making than the middle. The precise number stays open. The earliness does not. We tend to picture Earth as ordinary, an average rock circling an average star, and in most ways it is. But measured in time, in its position along the whole span of when worlds get to exist, it is strikingly early. We have been imagining ourselves walking into a party already in full swing. The interesting guests long arrived, half of them already gone home, the best of the conversation used up before we ever reached the door. The truth looks more like walking in among the first few through the door, into a room that has barely been furnished yet, one that will go on filling for longer than anyone here could stay to watch. None of this shows up if you measure Earth against ourselves. It only shows up once you measure Earth's arrival against the arrival of everything else. And that earliness is not a guess dressed up in decimal points. It is something we can read directly, in the light still arriving from the edge of the sky. Look at what is actually arriving from the edge of the sky, and the method becomes clear. Looking far out into space is not looking outward so much as looking backward. A galaxy a billion light years away shows you that galaxy as it was a billion years ago, not as it is now. Push the distance out further and the picture gets younger still, back toward a universe still catching its breath after the beginning. This is not a metaphor. The light left those galaxies long before Earth existed, and has been crossing empty space ever since, arriving tonight, carrying an old photograph of a young universe. Gather enough of that light, across enough distances, and the scatter of galaxies stops looking like a random field, and starts looking like a timeline. It charts, point by point, how fast the universe was building stars at every stage of its history. The way growth rings in a tree trunk record every year the tree was alive. The shape of that timeline is not flat. Star birth rose to a furious peak when the universe was only a few billion years old, a stretch astronomers sometimes call the high noon of cosmic star formation. Since then, it has been declining. We live well down the far side of that peak now, on the long, slow afternoon of a universe that still makes stars, just not at the rate it once did. Declining is not the same as finished. There is an enormous reserve of gas out there that has never been folded into a star, drifting inside galaxies that have not yet collapsed it. That gas is unlit, unshaped, and unspent. It is the raw material for every world still to come, sitting in the dark like flour that has not yet been made into bread. Where that future material sits tells you something Earth's own address does not. Our galaxy has already spent much of its store of star-making gas. It passed its most fertile years long ago and now builds new stars at a fraction of its youthful pace. The great nurseries of the future lie elsewhere, in small dwarf galaxies that sip their gas slowly across enormous stretches of time, and in giant clusters holding reservoirs that will not finish collapsing for trillions of years. It is there, over the coming billions and then trillions of years, that most habitable worlds will finally be born. Earth did not form in that coming wave. It formed before it, in a galaxy that got going early and fast, ahead of the crowd of galaxies still waiting their turn. Not simply first in time, first in place as well. Two separate races, and Earth won both of them early. Winning early does not mean winning alone. Rocky, potentially living worlds already number on the order of 10 to the 20th power within the observable universe. That same staggering count from before, and every one of them is only the opening installment. Being early is not the same as being rare. Not a lonely handful, scattered thin across an empty sky. A wave, an enormous first wave inside a universe that will go on to build a far larger second one, long after this one has finished forming. But here is the part worth sitting with, because it will matter later. We arrived while the universe is still young, which means the sky above us is still crowded. Point a telescope outward tonight and you can count hundreds of billions of galaxies, more than every grain of sand on every beach and every desert on Earth, combined, stacked back almost to the beginning. Their light lets us read the whole history of how the universe grew. The same history just described. A world forming in the far future will not get that. By then, most of those galaxies will have been carried beyond view, swept past the reach of any telescope by the same expansion that is slowly separating them now. That future world will look up into a far emptier sky and have almost nothing left to read. It will not even know that what it sees is only a fragment, because it will have no earlier picture to compare against. Being early is being born while there is still a view. Hold on to that. It will matter enormously by the end. There is one more way to measure how near the front we sit. The great majority of worlds that will ever hold life do not orbit a star that exists yet. The dim, patient red stars around which most future life will gather are, for the most part, still unborn, still locked up as cold gas inside galaxies that have not made them into anything yet. 9 in 10 habitable worlds still to come does not just mean empty planets circling stars we already know about. It means suns that have not been lit, homes with no landlord, built around lamps that have not yet been switched on. So look backward from this moment and worlds thin out fast, fewer and fewer, until you reach a stretch of cosmic history with essentially none at all. Look forward and they multiply, for billions of years and then for trillions, until the great bulk of every habitable world that will ever exist has finally formed. We sit on the hinge between those two directions, almost nothing behind us, almost everything ahead, not the position of an average world picked at random from all of time, the position of one near the very head of a line that has barely started to form. Sit with that position for a moment. Behind it, a thin scatter of worlds thinning toward nothing. Ahead of it, a swelling crowd stretching out past any date we can picture, and Earth holding the hinge between them, closer to the empty end than to the crowded one, which raises the obvious question, and it is worth asking plainly. If we are this early, why did we not come earlier still? Why not a billion years sooner, while the universe was younger and the whole future still lay open ahead of it? What kept a world like this from forming closer to the beginning? Something was missing. And it was not luck. Push back far enough into the earliest stretch of the universe and you run into a wall. Not a wall of time, a wall of material. There was almost nothing there to build with. What was missing, exactly? Go back to the years just after the beginning, and the universe held almost nothing but hydrogen and helium, the two lightest gases there are, the leftovers of the very first moments of everything. No rock, no iron, no carbon, no oxygen. Nothing a planet could be shaped from, and nothing a body could be shaped from either. If Earth had tried to form then, it would have found the shelves empty. This is the flaw under the whole story. The reason a world like ours could not have arrived any sooner than it did, no matter how much time was technically available. Consider what you are actually made of. The carbon in every one of your cells, the oxygen filling the water inside you, the calcium holding up your bones, the iron carrying oxygen through your blood, the phosphorus and nitrogen wired into every strand of what makes you, you. None of it existed in that first stretch of cosmic history. Every atom of it was forged later, inside the crushing heat and pressure at the center of a star, and released only when that star died, thrown out on stellar winds or blasted across the dark in a supernova. The ground under your feet came from the same furnaces. Earth's rocky mantle, its iron core, the whole solid planet, cooked inside stars that had already died before the sun ever lit. Not assembled from raw ingredients lying around at the beginning, manufactured later by fire. So building a world like this took stars, plural, and it took their deaths. The first stars formed somewhere between 100 and 200 million years after the beginning, out of nothing but hydrogen and helium, and they were nothing like the sun. With no heavier elements in them to slow the burning down, they grew enormous, blue-white and savagely bright, many times heavier than the sun, and they tore through their fuel and died fast. Not billions of years, millions, a blink, compared to a star like ours. But in that short, violent life, each one did the one thing that mattered. It fused a first batch of heavier elements deep in its core, and in dying it threw that material out into the surrounding gas. The first carbon, the first oxygen, the first iron, scattered into clouds that had never held anything heavier than gas before. The next generation of stars condensed from those enriched clouds, burned a little longer, fused a little more, and died in turn, seeding the dark a second time, then a third. Each round left the surrounding gas a little richer than the one before it. That is the whole mechanism, one generation of stars after another, quietly stocking shelves that the universe had started out with empty. It ran entirely on the lifetimes and deaths of stars, and there was no way to speed it up. No shortcut around waiting for enough of them to live and die. You cannot have a rocky planet before the universe has manufactured rock. You cannot have water-based chemistry before there is oxygen. And there is no oxygen until a star has made it and died to let it go. So the enrichment had to climb, generation by generation, until it crossed a threshold. And only once it crossed that threshold could anything like Earth begin to form, let alone grow anything living on its surface. That threshold was not reached until several billion years of cosmic history had already gone by, only a few billion years before the sun lit. Not near the beginning of everything. Near us. It helps to say plainly what that means for a world like ours. Every rocky planet anywhere in the universe, not just Earth, had to wait on the same slow accounting. No shortcut existed for any of them either. No faster path around the requirement that stars live, die, and leave their ashes behind before rock and water and air can exist anywhere at all. The flaw is not a peculiarity of our solar system. It is a universal condition, paid in the same currency of stellar generations everywhere it applies. Here is what that does to the oldest version of the ancient aliens idea. The one that imagines beings ancient beyond conception, present almost since the universe first switched on, watching from some impossibly early vantage while our own solar system was still unformed dust. They could not have been there. For that first long stretch, there were no worlds for them to live on, and no atoms heavy enough to build them from, even in principle. Not a civilization delayed by circumstance. A civilization made physically impossible by chemistry. The deep past was not a place elder civilizations had endless time to rise in. It was a place that lacked the raw materials for any civilization at all, ours or anyone else's. The first real chance came late in a relative sense, and it came not long before we took it. None of this is nailed down to the decimal, and it is worth saying so plainly. Exactly how much enrichment a system needs before it can grow rocky worlds and living chemistry is still an open question. Life might get by on less than we assume, forming around stars poorer in heavy elements than the sun, which would push the floor a little earlier than this account suggests. There are old stars Stars that formed when the universe was still young and thin on heavy elements that do turn out to host rocky worlds. A hint that the threshold may sit lower than once thought. So the exact line is not settled. What is settled is that a line exists, that the early universe was too bare to build anything like us, and that closing that gap took billions of years regardless of exactly where the line falls. We arrived close to the earliest moment a world like this could plausibly have existed at all, and the ashes that made that possible did not just build a planet under our feet, they built us too. That part of the story is still ahead. Look closer at the stars that did this work. The first stars were not stars like the one warming you right now. They were furnaces built from almost nothing. Clouds of pure hydrogen and helium, with nothing heavier mixed in to help the gas cool and break apart into smaller pieces, could only collapse into single, enormous bodies, some of them tens of times the mass of the sun, some of them hundreds, a single star outweighing an entire cluster of ordinary ones. There was nothing gentle in how they formed, and nothing gentle in how they lived. They burned blue-white, hotter than anything shining in the sky today, and they burned fast. A few million years, sometimes less. A flicker, measured against a universe already counted in billions. Then they died, many of them in explosions violent enough to outshine an entire galaxy for weeks at a time. One point of light, briefly brighter than 100 billion suns put together. And that violence was only the beginning of the pattern. In the fusion at their core, and in the searing instant of the explosion itself, they forged elements heavier than anything that had existed before, and threw them out into the surrounding gas. That gas did not sit still. It cooled, gathered, and collapsed again into a new generation of stars carrying a trace of what the first ones had left behind. Those stars lived, in their turn, and died, adding a little more. Somewhere in that slow accumulation, for the first time, a cloud held enough heavy material that what condensed from it was not just another ball of hydrogen, but something with rock in it. The cycle repeated, generation after generation, each star living and dying and leaving a little more than it inherited. There was no way to speed it along. The only place the universe can make a heavy atom is inside a star, and a star only gives up what it has made by dying. No amount of waiting around a single star would have done it. It took a whole succession of them, one funeral after another, before the surrounding gas held enough to matter. The wait was not a delay in the ordinary sense. It was the minimum time the universe needed to build anything solid at all. Here is what that means for you. Specifically, every heavy atom in your body is older than the sun. Not figuratively older, actually older, made inside a star that lived and died, before our own star had even condensed out of its birth cloud. The iron carrying oxygen through your blood right now was forged in the core of a dying star, thrown into the dark in that star's last violent moment, and drifted through space for a long stretch of cosmic time before it ever found its way here. That is not a metaphor. It is the literal history of the matter you are made from. It could not have happened quickly. Not in a year, not in 1,000 years. It took the slow furnace of the whole galaxy, working across billions of years, to make it. You did not arrive on Earth carrying borrowed material from some endless stockpile. You arrived carrying what a handful of dead stars had only just finished making. Trace the pieces further and they scatter across different kinds of dying. The carbon that forms the backbone of nearly every molecule in you came mostly from stars of moderate size. Stars that swelled gently near the end of their lives and breathed their outer layers off into space rather than exploding outright. Much of the oxygen filling the water inside you came from heavier stars, blasted outward in the explosions that ended them. The iron in your blood, and the iron at the center of the earth beneath your feet, came largely from those same titanic explosions, and from something rarer still, the collisions of the crushed, burnt-out cores those explosions leave behind. Whatever is heaviest in you, the trace metals scattered thin through blood and bone and soil, came from the most violent events the universe stages at all. You were not made from one source. You were assembled piece by piece from the ash of many different deaths, gathered across billions of years into a single cloud that eventually became the sun and the earth and you. We are early, built from the leavings of only a handful of stellar generations, in a galaxy that has barely begun making the ones still to come. None of the stars that started this were seen by anyone. We have never directly observed a first star. They were too short-lived and too long ago, gone before there was anyone or anything able to watch. What we have instead are witnesses one step removed, their grandchildren. Scattered through the galaxy are stars almost as old as the galaxy itself, formed early, out of gas the generations before them had barely touched. They carry only faint traces of iron and carbon in the light they give off, in what astronomers call a spectrum, the same way the color of a flame tells you what is burning inside it. A young star forming today would carry far more. Reading these old, faint stars is close to reading the opening pages of the record directly, and what those pages say is plain. For a long stretch near the beginning, there was almost nothing to build a world from. It gathered slowly, one dying generation at a time, until, at last, there was enough. The first stars themselves left no survivors to question. Their grandchildren are the only ones still standing to testify, and their testimony agrees, all of it, on how little there was to work with, and how long it took to change that. So now we know where this begins. The material for a body, for a planet, for anything solid at all, only became possible once a few billion years of that slow burning and dying had already passed, and we arrived close behind that opening. What we still do not know, what none of this has told us yet, is how long the story runs forward from here. That is the harder question, and it is the one that decides everything. The answer is not written in the ashes. It is written in the stars that have not finished burning yet. The age of life does not run for billions of years. It runs for trillions, and almost the entire span of it is still ahead of us, because the stars that will host most of that life have barely started to shine. To see why, look away from stars like the sun. Look toward the small ones, the dim, red ones, the kind that never make it into a photograph of a bright night sky, because they have almost no light to spare. A typical red dwarf carries 1/10 to 1/5 of the mass of the sun. It glows a deep, banked red, and it puts out only a sliver of the sun's light, sometimes less than 1,000th. Not one is bright enough to see from Earth with the naked eye, and yet they outnumber every other kind of star combined, ordinary stars, giant stars, all of them together, stacked against the red dwarfs alone. The nearest star to the sun, Proxima Centauri, is one of them, close enough to count as a neighbor, and still too faint to spot without a telescope. Multiply that pattern out across the whole galaxy, and it holds everywhere. The stars that get noticed, the bright ones, the ones that end up named and photographed and pointed to in the night sky, are the exception. The stars that will actually decide how long the age of life runs are the faint, ordinary majority most of us have never thought about at all. A red dwarf does not burn the way the sun burns. The sun spends its fuel quickly, fusing hydrogen at a hurried pace to throw off enough light to warm a whole system of worlds. Where the sun burns like a match struck and left to gutter, a red dwarf burns like a coal banked low in a stove. The most patient kind of fire the universe knows how to make. It sips its fuel. It fuses hydrogen slowly and stirs its own interior so thoroughly, folding fresh fuel back down toward the core again and again, that almost nothing goes to waste. A small one, around 1/10 the mass of the sun, can burn steadily for something like 10 to 12 trillion years. Set the current age of the universe against that number. 13.8 billion years against 10 trillion. The whole of cosmic history so far, the beginning, the galaxies, the sun, all of it, comes out to less than 1,000th of a single one of these stars' lives. Not one of them has died. Not one. Anywhere in the universe, in any galaxy we can see, there has simply not been time. Every red dwarf that has ever formed is still burning right now, still in its infancy, working patiently through a fuel supply it will not exhaust for longer than the universe has so far existed, many times over. The universe is not old enough to have lost even its longest-lived stars. Everything we could ever say about how a red dwarf ages, past its calm middle years and into whatever comes at the end, is still projection, because no one has ever watched one finish. Hold that against what life actually needs. Not a spark. Time. On Earth, it took something like 4 billion years, most of the planet's whole existence, to go from the first simple cells to anything that could look up and wonder. Long stretches of stable warmth are what biology seems to want more than almost anything else. And a red dwarf, patient past any human sense of the word, can offer stretches the sun will never live long enough to give. It is not a question of whether a world orbiting one has enough time. It is a question of what to do with all the time it would have. Weigh all of that together. Every kind of star, how many of each exist, how long each one keeps a world warm, and ask when life is most likely to be found across the whole span of cosmic time. The astronomer Abraham Loeb and his colleagues ran that calculation. The peak does not fall now. It falls around 10 trillion years from now, gathered around exactly these small, patient, long-burning stars. Not soon, not relatively soon, 10 trillion years. That is the long afternoon of the universe. The stretch when life, if it happens at all, happens in the greatest numbers, around stars that will still be glowing steadily long after every star like the sun has gone dark. We are nowhere near it. We are standing in the first thin light of morning, warmed by a bright, fast star that will be dead long before the real day even begins. But here's the fact the whole calculation leans on, and it has not been settled. Red dwarfs are calm in old age. They are not calm when young. Early in their lives, they throw off enormous flares, sudden violent bursts that could strip the air and water off a nearby world before it ever gets the chance to settle into anything resembling stability. Their habitable zones, the narrow band of orbits warm enough to hold liquid water, sit close in. So close that a planet there risks becoming tidally locked. One face forever turned toward the star, and one forever turned toward the dark. And through the star's long, brighter early phase, before it settles into its patient old age, a world in that zone may be baked hard enough to lose its oceans outright, long before life ever gets a chance to start. We do not yet know whether the most common stars in the universe can hold life at all. If those problems turn out to be fatal, the far future is not the great age of life after all. The long afternoon never comes, and a civilization appearing now would not be early. It would simply be ordinary, sitting in the only stretch of time life ever gets. Loeb said as much himself. The result holds only if life around small stars is not ruled out. That is the live edge. The case that we are early is strong, but it leans in full on a single unanswered question about the stars that outnumber every other star in the universe. And that question is still open, sitting underneath everything that follows from here. Set the uncertainty aside for a moment, and just add up what is settled. A floor behind us we could not have arrived before. A vast stretch of patient fire still ahead of us. Put those two pieces next to each other, and the shape of where we stand starts to come into focus. A floor behind us. A vast stretch of patient fire still ahead. Put those two pieces together and something becomes visible that was not visible before. A shape. Life could not begin until the universe had spent billions of years forging the heavy elements a body needs. So there is a floor, and we are not far above it. The age of life then runs forward for trillions of years, peaking something like 10 trillion years from now, around stars that have barely started to burn. And more than 9 in 10 of all the worlds that will ever host life have not been born yet. Stand back from all three of those facts at once and ask the plain question, where does this moment sit in the whole distribution of when life is possible, from its first stirrings to its last flicker? It does not sit in the middle. It sits at the very front, in the first thin fraction of the whole. That should feel strange, and here is why. If life is reasonably common across the universe, the natural assumption is that we are an average example of it, arriving at an average time. somewhere in the thick of things. Find yourself somewhere. And the safe bet is that you have landed somewhere typical, because typical is where most things are. Run that reasoning here and it breaks. The typical time for life, the stretch when most of it exists, is trillions of years in the future, gathered around small red stars that have barely begun to shine. If we were a typical example, we would almost certainly find ourselves there, not here. And yet here we are, at 13.8 billion years, roughly 10 trillion years before the peak. Not typical. Extraordinarily early. The astronomer who ran that calculation put it in exactly those terms. Present-day life, he said, may be premature. It is a precise word, and a slightly unsettling one. It means we arrive before the main event, ahead of the time the universe is really set up to support life in any abundance. Like a guest who shows up not just before the party fills, but before most of the food has been made. Hold that claim carefully though, because it would be easy to overstate. Early is a statement about probability and timing, not a certainty about any single world. It does not say there is no other life out there right now. There may well be. It says that measured against the full sweep of cosmic time, this moment is a remarkably early one for life to appear at all, and the whole claim rests on something already flagged, on the long future actually turning out to be habitable, on red dwarfs actually being able to host life. If they cannot, the distribution changes, and we may be closer to ordinary than early. Think about it the way you would think about a drop of water. Find yourself as one drop among an ocean, and the safe assumption is that you are somewhere in the ocean itself, not out at the rare splash thrown up at the edge of the very first wave. Applied to time, the same logic says we should expect a typical moment for life, the crowded far future, trillions of years from now. Finding ourselves here instead, so far out ahead of that crowd, is exactly what makes our position strange. There are only a few ways to read that, and each is interesting on its own. Either we are genuinely among the first, real early arrivals in a universe that goes on to fill with life long after we are gone, or something is wrong with the assumption that the far future is where life mostly lives, which would mean the red dwarfs cannot host it after all, and the true crowd, whenever it exists, is smaller and nearer than the raw numbers suggest. We cannot yet tell those two readings apart, but notice what they share. In the first, we are early in a universe that goes on to teem with life. In the second, we are early in a universe that stays sparse, one of only a few that will ever appear at all. Neither one hands us a comfortable middle. The word premature survives both readings. Put it as a wager, and the shape gets even clearer. Guess blind where in the whole sweep of cosmic time, a randomly chosen living world would land. And the smart guess is the crowded far future, gathered around an enduring red star some 10 trillion years from now, because that is where the numbers say most living worlds will be. We are not there. So either we drew an extraordinarily unusual ticket, landing in the rare early moment, or the prediction itself is off, and the far future never feels the way the calculation expects. There is no third option that sets us down comfortably in the middle. The middle, by the timing involved, is trillions of years away. Whichever way the wager falls, it places us at the leading edge. But here's the objection that deserves its full weight, not a softened version of it. Maybe we are not early at all. Maybe life is only ever possible in a narrow span around right now, because the small red stars turn out to be barren, sterilized by their own flares and their violent youth before they ever settle down. If that is true, the great late age of life never arrives. The crowd never shows up, and a civilization appearing now is not early. It is ordinary, sitting in the only stretch life was ever going to get. That would dissolve the whole reframing at a stroke. It cannot be ruled out, not yet, because we still do not know whether the most common stars in the universe are fertile or sterile. The honest position is a conditional one. Our earliness is real if the far future turns out habitable, and uncertain if it does not. And the single fact that would decide between them is the one fact we have not settled. The same reasoning reaches all the way down to this exact moment. If most living worlds lie in the far future, then most conscious moments that will ever happen, most instances of something looking up and wondering about its own existence, also lie in the far future, gathered around those same patient stars. By the plain logic of where most observers are, you should expect to find yourself there, in the crowded late age, not here in the empty early one. And yet here you are, reading this, at 13.8 billion years, roughly 10 trillion years before wandering is supposed to be common at all. Either that is an extraordinary coincidence, or the far future is not as full as the numbers suggest. There is no comfortable third reading. The very fact of being aware this early is one of the strangest features of where you stand in all of time. And once a fact sits that close to home, it stops staying abstract. It stays close to home because there is an answer waiting inside it, one this whole account has been building toward, without saying so outright. The ancient ones are not a mystery still waiting to be solved. They are not scattered fragments sitting in some older stretch of time for us to dig up. The ancient aliens are us. Say that plainly, because it deserves to be said plainly. The impossibly early ones, the precursors who were supposedly already here before anyone else arrived, the civilization whose existence predates every other, are not hidden behind us. They are sitting here right now, wondering where everyone else is. We are the ones who came first. Strip the idea down to what it actually claims, and it gets simpler, not stranger. Take away the gods and the monuments, the myths of builders who raise things no one else could raise. What is left is a claim about time. It says that somewhere, some beings arrived early enough that everyone who came after inherited a universe those beings were already living in. The old ones are defined by being first. Nothing else, not wisdom, not power, only timing. And on the question of who actually gets to be first, the physics has already answered. Almost no one could have come much before now. The heavy elements were not ready. The worlds had nowhere to condense. The deep past was too early and too barren to hold anyone at all. Meanwhile, the future stretches out for trillions of years, with the great majority of every habitable world still unborn inside it. Almost everyone who will ever exist exists after us. Now run the timeline forward and look back from the far end of it, 10 billion years from now, or 100 billion. A civilization gathers around one of the patient red stars, deep in that long afternoon of the universe. They search their own past the way we search ours, looking for whoever came before them. What they find, near the very beginning of cosmic time, in its first thin sliver, is a scattering of the earliest worlds ever to form, circling bright, fast stars that burned out ages before the civilization's own sun had even condensed. Among those first worlds is a small blue one, circling an ordinary yellow star, that briefly held a civilization right at the dawn of things. Impossibly long ago, in an era when the universe was still young and strange, still crowded with galaxies they can no longer see. To them, that is the deep, ancient past. Those first ones are the old ones, the precursors, the beings who were already here before everyone else. That is us. That small blue world at the dawn of things is the Earth. Right now, today. Sit with that for a moment before moving past it. Every time we have imagined the ancient ones, we have imagined them elsewhere, in a different sky, on a different world, further along some path we have not walked yet. It never occurred to most of us to check whether the path runs the other way, whether the beings who came earliest, closest to the beginning, might simply be looking back at their own reflection. They are not elsewhere. They are here, on this world, reading these words, wondering the same thing every early arrival wonders. Where is everyone else? Being the ancient ones has nothing to do with being advanced or wise. It is simply about when we showed up. To hold that title in the sense every legend means it is not to have built the most or understood the most. It is only to have arrived earliest, to have already been present when everyone else showed up, so that all of them inherit a universe we were already standing in. That is a claim about position, and nothing more. Whoever is alive right now occupies the earliest possible seats, not because we earned them, but because we happen to open our eyes this close to the beginning. Hold both ends of that at once. Looking back from where we stand, there is almost no one to find, because there was almost no one before us. Looking forward from the far end, trillions of years on, whatever is alive then will search all of cosmic history and find, near its very beginning, the earliest worlds and minds that ever managed to exist. We are sitting inside that first sliver right now. From where the future stands, this moment is already the deep past, and we are the ones who fill it. It is the same thing we already do with our own beginnings. Look back at the earliest stretch of human history, and there they are, the first ones, the ancestors, the people we tell stories about and trace ourselves back to. Lift that same frame up to the scale of the whole universe, run it forward across trillions of years, and a civilization in that long afternoon would do exactly the same thing with the earliest worlds and minds it can find. The route they trace themselves back to would be us. We are not the ones who will look back and marvel at our elders. We are the elders somebody, someday, might look back and marvel at. There is something strange in holding a title we never earned. The ancient ones of legend are always advanced, wise, powerful, their age matched by their achievement. What the timing hands us looks nothing like that. A civilization 10 trillion years from now could be unimaginably beyond us in every way that matters, and it would still look back, searching for its first ones, and find us. Primitive, brief, early. Occupying that seat not by greatness, but by accident of when. There is something humbling in that, and something clarifying too. The role of precursor is not a prize for being best. It is a consequence of being early. And we are early. So the seat is ours, ready or not. Which reverses something that has always run one direction. In every version of the ancient alien story, influence flows down from the old ones toward us, from elders to latecomers who inherit their teachings and their traces. The physics turns that arrow the other way completely. We are not downstream of anyone. There was almost no one upstream to send anything down to us. Whatever passes between the first ones and everyone else has to pass from us forward, out into the trillions of years and the worlds not yet born. We are the source, not the inheritor. But that whole picture leans on something not yet settled, that somewhere out in that long afternoon, life actually takes hold. If those patient red stars turn out to be fertile, if the early flares and the tidal locking do not sterilize every world around them, then we are the precursors of an enormous population still to come, the first of a great many. If those stars turn out to be barren, there may be no one out there to look back at all. No crowd, no memory, no one for us to be ancient to. We would simply be an early flicker, in a universe that never filled, precursors to nothing at all. We cannot yet tell which one is true. But notice what does not change either way. Whether we turn out to be the old ones of a crowded future, or the only old ones there will ever be, the precursors are not behind us. They never were. The direction we searched in was always the wrong direction. What something this early could actually leave behind is a harder question than it sounds. Every being ever called an ancient one is assumed to have left something behind. Ruins, a structure still standing after its builders are gone, a record scratched into rock that someone later has to work to read. If that title belongs to us now, the question turns and points itself straight at our own hands. What could we possibly leave that would still be here, still legible by the time anyone in that far future comes looking? Start with the hard answer. Almost nothing we have ever built will survive. We like to imagine our monuments outlasting us, our cities standing as ruins for some distant mind to wander over, the way we wander over the oldest walls still standing on this world. But the Earth does not hold still long enough to keep that promise. Its surface is never finished. Mountains rise and grind themselves back down to nothing within tens of millions of years. Whole continents get dragged under and remade. The seafloor is swallowed and poured out again as something new. Set that against the trillions of years still ahead of us, and even a few 100 million years, barely a breath on that scale, is enough to resurface the ground a city was built on. Not stone, not steel, not even ash. A smudge that washes out before the ink has dried. Our cities will not even register as a layer in the rock. So if anything of us is going to last, it has to get off this planet. and a little of it already has. On the moon, the story runs the opposite way. There is no wind there to carry dust across a footprint, no rain to soften an edge, no ocean to swallow a track, nothing at all reaching down to smooth away what has been pressed into that grey surface. The prints left by the handful of people who ever walk there are still sitting exactly where they were set down, sharp at the edges, undisturbed. The landers that carried them down are still there too, tracks beside them in the dust. Equipment left behind exactly as it was set down, all of it held in vacuum like a single frozen instant. Only the slow, patient rain of micrometeorites and the creep of radiation from space will wear any of it down eventually. And that erosion works so gently, it could take millions of years to finish the job. A single human footprint could outlast every pyramid we ever built, every cathedral, every city we ever poured concrete over. Not the living world, the still one. The dead world turns out to be the better archive. Stillness keeps what life erases. But here's where it gets stranger. A few things we made have gone further than the moon ever could, past the edge of the planets, out where the last of the sun's wind gives way to true interstellar dark. 4 small machines are still moving, still going, and never coming back. 2 Voyager probes, 2 Pioneers, launched decades ago, already faint or already silent, coasting now on paths that will carry each of them out among the stars for longer than almost anything else we have ever touched. With no air out there to corrode them and next to nothing in that emptiness to strike them, they should stay essentially whole for an extraordinarily long stretch of time, hundreds of millions of years at least, quite possibly billions, drifting in slow loops around the galaxy long after the sun itself has swollen, reddened, and gone dark. Each one is carrying something deliberate. Bolted to the side of each Pioneer is a small etched plaque, a diagram of where it came from and what kind of being sent it. Sealed inside each Voyager is a golden disc holding sounds and images of this world, chosen with care, the kind of thing the ones who built it thought worth saving. None of it was sent expecting to be found. It was sent the way you might seal a note inside a bottle and drop it over the rail of a ship in the middle of an open ocean, knowing exactly how long the odds are, and doing it anyway. If anything of us is ever encountered by anything out there, this is most likely what it will be. A cold, quiet object drifting in from an impossibly early time, carrying a message no one who sent it was ever sure would be read. And here the honesty matters more than the comfort. The odds are almost nothing. Vanishingly small. Smaller still than anything out there would ever notice. The galaxy these probes are crossing is around 100,000 light-years from one edge to the other, and each machine riding through it is smaller than a car, dark, silent, and utterly cold. Shrink that whole galaxy down to the width of a small town, and one of these probes would be a speck of dust, drifting somewhere out past the last house on the last street. The chance that a speck like that ever passes near another world is close to nothing. The chance anything on that world notices it sliding through the dark is smaller still. The footprints on the moon will last, but the moon is one small dead body among an uncountable number of dead bodies, with no reason for anyone to ever come looking there. In all likelihood, everything we leave simply drifts and waits and is never found. A message in a bottle thrown into an ocean so wide that no shore is ever reached. Deep time may swallow every trace of us and never even leave a puzzle behind. Only an early flicker that came and went with no one ever the wiser. That is what gets left behind. It is not, it turns out, the only thing being early gives us. There is something else being early gives us. Something that was named once already and then set aside for later. A difference that was called, at the time, something that would matter enormously by the end. This is the end that promise was pointing toward. The sky above us is emptying, slowly, silently, and permanently. The cause is not distance by itself, it is the growth of space between us and everything far away. Every distant galaxy is being carried off as that space stretches, and the farther away a galaxy already sits, the faster it recedes. because there is simply more stretching space lying between us and it. Push that far enough, and you reach a line where a galaxy is carried away faster than its own light can ever cross back toward us. Past that line, nothing it does can reach us again. Its light stretches, reddens, dims, and eventually slips below anything any instrument could catch. This is not a future problem. It is already underway. Most of the galaxies whose light is reaching us tonight have already crossed that line. Their light still arrives. Their present moment is already sealed away from us forever. Run that forward to the civilizations of the long afternoon, 10 billion years from now, or 100 billion, gathered around one of the patient red stars. By then, the work will be nearly finished. Our own galaxy and the small cluster bound to it will have merged into a single island of stars, and everything beyond that island will have been carried past the horizon, too far and too fast for its light to ever find its way back. There will be no faint smudges of neighboring galaxies to point a telescope at, no faraway light to argue over, nothing at the edge of vision worth chasing. A mind looking up from that island will see one galaxy. Around it, nothing. Total, featureless black. Wait. There is no way for them to know anything else was ever there. They could be sharper than we are, build instruments far beyond ours, reason without a single mistake, and still conclude, correctly by their evidence and completely wrong in fact, that their one galaxy in an empty void is the whole of everything. Fixed, alone, without a beginning. The relic light of the universe's birth, still faintly crossing our sky tonight, will by then have stretched past anything any instrument could measure. The other galaxies whose motion reveals that space is expanding will be gone from view, so the expansion itself will be invisible, and every trace that there was ever a beginning at all will be gone along with it. Two cosmologists worked through exactly this future in careful detail, Lawrence Krauss and Robert Scherer, and what they found was precise, and it was bleak. An honest observer in that era, doing the best science available to them, would look out at one still island of stars and reasonably decide that this was all there had ever been. Not a guess, not a failure of their instruments or their reasoning. The true history of the universe would be unknowable to them, because the evidence for it would be physically gone. We are early enough to still hold every piece of it. We can count galaxies by the hundreds of billions. We can find the afterglow of the beginning sitting in our sky right now. The literal light of the universe's birth, released less than 400,000 years after everything started. A sliver of time so early against the 13.8 billion years since that it sits closer to the first hour of a life than to any later day of it. We can measure the expansion directly in the redshift of galaxy after galaxy. We can read the leftover ratio of the lightest elements and trace the whole story back almost to the first minute. None of that will exist for the ones who come after. The window is open right now, and it has been closing the entire time we have been looking through it. What closes is 3 separate proofs, each erased its own way. The first is the outward flight of the galaxies, the direct sign that space itself is growing, gone once the last visible galaxy drifts past the horizon. The second is the relic afterglow, stretched longer and longer until it falls below anything any instrument could ever catch. The third is the leftover mix of hydrogen and helium from the first few minutes of everything, buried as later generations of stars process and reprocess the gas. One proof at a time, the case for a beginning is taken apart. It is worth being plain about what that means. Not blurred, not faint, gone, in the sense that no experiment run by anyone, however patient or however well built, could ever recover it again. In something like 100 billion years, all 3 will be gone, and whoever is looking up by then will have nothing left to read the true history from. The road between every galaxy and every other galaxy is lengthening faster than light can ever travel down it. The truth about the origin of everything then is not a fact sitting patiently in the universe, waiting for someone clever enough to find it. It is perishable. It is written in the sky right now in 3 separate hands, and every one of those hands will eventually fall silent. That faint glow across the whole sky is the closest thing to a baby photograph of the universe that will ever exist, and we happen to live inside the narrow stretch when it and its two companion proofs are all still legible. Being early may be the only seat anyone ever gets from which the whole of that story can be read. There is an honest caution folded into this too. The exact schedule depends on how dark energy behaves over stretches of time far longer than anyone has ever watched it, and that is not fully settled. If it changed character in the deep future, the timeline could shift. But everything we currently know points the same direction. The expansion keeps accelerating, the horizon keeps drawing in, and the sky keeps emptying on a schedule already running. A little over a century ago, before anyone had seen the other galaxies or measured the expansion, our own astronomers looked at one galaxy and reasonably thought it was the whole of everything too. We were not wrong, because we reasoned badly. We were early, in a smaller way, inside our own story. Now, hold that same mistake and imagine it made permanent, built into the very structure of what is left to see. That is the privilege sitting underneath everything covered so far. Quieter than the loneliness, easy to miss beside it. We are early enough to still see the whole of it laid out. And for exactly that reason, we are very likely the only ones who ever will. There is another kind of emptiness, one we have listened for rather than looked at, and it has troubled us for the better part of a century. For decades we have pointed our instruments at the galaxy, a barred spiral of a few 100 billion stars, more than 13 billion years old, surely crowded with worlds. We have listened for a signal, a beacon, a stray transmission, any narrow beam or repeating pattern that nature does not make on its own. Across all of it, we have heard nothing. No confirmed sign anywhere that another civilization exists, or ever has. Not a whisper riding a radio band. Not a flicker of light that does not belong to a star. For most of a century, that silence has been treated as a puzzle, and a troubling one. The kind that unsettles more the longer you sit with it. The puzzle has a familiar shape. The galaxy is old. Hundreds of billions of stars, many of them circled by worlds, have had more than 13 billion years to produce something. If even a tiny fraction of those worlds produced life, and a tiny fraction of that life produced civilizations able to reach across the dark, the galaxy should have been seeded long ago. Some of those civilizations should be very old by now, old enough to have crossed the galaxy many times over. We should see traces everywhere. Instead, we see nothing. And the usual answers to that are dark ones. Maybe civilizations destroy themselves not long after they learn to reach outward, turning the same cleverness that built the transmitter against themselves. Maybe something out there finds and ends them first. Maybe life itself is so rare that we are, for practical purposes, alone. Each answer reads the silence as evidence that something, somewhere, keeps going wrong over and over for everyone who has ever tried. But that framing leans on the same assumption this account has spent 13 sections taking apart, that the galaxy is old in the way that matters, with ample time already behind it for the old ones to rise, spread, and vanish. Flip the timeline and the puzzle comes apart in your hands. If life is cosmically premature, if the heavy elements were only recently finished, and the great age of life still lies trillions of years ahead, then the silence needs no catastrophe to explain it. The others are not gone. They are not here yet. We are not standing in a great hall that has somehow emptied out, wondering what killed everyone in it. We are among the very first to arrive in a hall that will slowly fill over the next trillion years, long after we are gone. The seats are empty because we came early, not because we came late to a funeral. No mass grave, no plague of civilizations, not a graveyard at all. An early hour before the others have woken. That is what the reframing buys, and it buys it cheaply. It asks nothing extra of the universe. The dark explanations all require an added ingredient bolted onto the facts. Civilizations that reliably self-destruct, a hazard that reliably finds and ends them, or life so improbable it borders on miracle. The early reading adds nothing. It takes the timing we have already established elsewhere, the late flaw under life, the trillions of years still ahead, the overwhelming majority of habitable worlds not yet born, and simply notices that a universe this young has not had time to grow loud. The silence falls straight out of facts we already accept for other reasons. That does not make it certain. Being early does not prove we are not also alone. The quiet is just as consistent with life being genuinely rare, or with civilizations burning out for reasons we do not understand, as it is with simply being early. Nothing about the timing rules those darker readings are. It only stops them from being the only readings available. What earliness removes is not the possibility of disaster. It removes disaster as the only story the silence can tell. The emptiness may be innocent, it may not be. We cannot yet say which, and an honest account has to leave both doors open rather than quietly closing the frightening one. And the emptiness, whatever it means, is not for lack of looking. For more than 60 years we have swept the sky, pointing instruments at thousands of nearby stars, scanning enormous ranges of frequency, watching for pulses of light as well as bursts of radio, combing decade after decade of data for anything artificial. 60 years is longer than most of the people who started the search have been alive to see it continue. Nothing has held up. Not one confirmed signal. Not one unambiguous mark of another mind. The search is far from finished, and a silence like this is not proof that no one is out there. But the quiet is real, and it runs deep. And it is exactly what we would expect to hear if we were among the first to switch on our instruments in a galaxy where almost no one else has arrived. The sky stays quiet, not because the party ended, because it has not started. We have now traced the timing all the way through, from the heavy elements that had to be forged before we could exist, to the trillions of years still ahead, to the silence overhead that turns out to fit the same pattern rather than break it. What is left is the harder question, the one the facts alone cannot answer. If this is what being early sounds like and looks like, what does it leave us? What are we supposed to do with it? We do not get to know which we are. That is the plain truth waiting at the end of all this counting, and it refuses to soften. We cannot say whether we are truly the first, or only very early among many. We cannot say whether the future fills with life that will look back on us the way we have looked back for elders, or whether we are a lone early flicker in a dark that never lifts. We cannot say whether the silence overhead is the hush before a crowd arrives, or the hush of a hall that stays empty. The honest position holds all three doors open at once, because nothing we have actually closes any of them. And yet notice how much still stands without those doors ever closing. We arrived near the very start of an age that runs for trillions of years. 9 in 10 of all the habitable worlds this universe will ever build have not been born yet. Whatever else stays uncertain, that much does not move. We are early, by every reckoning available to us, sitting in the first thin sliver of the whole span in which life is even possible. And that single fact, solid under everything shakier stacked on top of it, comes with consequences that do not wait on the doors to open. Right now, tonight, we are holding a view of the universe the future will lose, the galaxies, the afterglow of the beginning, the whole readable story, still hanging in the sky, still on display, in a window that closes a little more with every year that passes. And whatever we leave behind us, footprints pressed into grey dust, 4 small machines drifting past the edge of the sun's reach, moves outward into a future we will never live to see. None of that should be dressed up into something it is not. Being early does not make us important. It does not mean the universe noticed us coming, or set anything aside, or is waiting on us for anything at all. It may mean we are profoundly alone, that the company we have spent 60 years listening for is not late arriving, only not here yet, and will not be here for longer than our whole species has existed, many times over. That is a real possibility. Not a worst case to be managed and quietly dismissed, a real one, and an honest account lets it stand, but sit with the position itself, faced without flinching, and something else is there too. If we are among the first, then we are also among the very few who ever get to see the universe whole before it starts hiding itself. We stand near the beginning, in the brief bright window, when almost the entire story can still be read straight off the sky. Whoever comes after us, in whatever numbers, will inherit a darker view and a quieter one, and most of them will never know how full that sky once was. They will not know what they are missing, because the evidence of it will already be gone. We know. We are here for the part almost no one else will ever get to see. Not a prize, not a consolation either, just the plain shape of where we are standing, near the front edge of all cosmic history, holding the one clear view there will ever be, for as long as we last. That is what we can hold on to, against everything else that stays uncertain. Whether the future fills or stays empty, we arrived near the start of the age of life, with almost all of it still ahead of us and almost none of it behind. That position does not depend on which door eventually opens. It carries its own weight. We hold a view the future will lose. We are built from the ashes of the few stars that lived and died before we did. And whatever trace of us survives, drifts forward into a time we will not be there to witness. None of that needs an answer to the bigger question. It follows from the plain fact of when we are. There is a harder edge under that privilege, and it deserves to stay sharp rather than get smoothed away. None of the future we are early to is a future we get to see. The long afternoon, the crowded age of worlds beyond counting gathered around patient red stars. All of it sits trillions of years ahead, and we will be gone long before any of it arrives. Our sun will have died. Our world will have gone with it. The reward for coming first turns out to be this. Arrive before the company. Stand in the empty early hall. Leave again before anyone else walks through the door. Whatever we hand forward goes out into a darkness we will never witness, toward a future that may or may not come, and that, if it comes, will know us, if it knows us at all, only as the faintest and oldest of traces. To be early is to be brief. To be brief is to miss almost everything that follows. That cost sits folded inside the privilege, and neither one cancels the other. What we make of that is not something the physics can decide for us. The physics can tell us when we are. It was never going to tell us what to feel about it. Whether the loneliness should weigh more than the privilege, or the privilege more than the loneliness, or whether, most likely, both sit in the chest at once and neither one wins outright. That part was always going to be left to us, sitting here on this one early world, in the opening minutes of a story almost none of which has happened yet. Somewhere in the galaxy tonight, that small red star is still burning, the way it was burning at the start of all this, having used almost none of its fuel, with 10 trillion years still ahead of it, before it so much as begins to dim. Around stars like it, the real history of life in this universe has not started yet. We expected to feel small standing next to that kind of time, and we do. But there is something else in it too. Something we did not expect going in. We went looking for the ancient ones in our past. In old stories, in old stone, over our shoulder, and the whole time we were facing the wrong way. If there are beings who came early enough that everyone afterward inherits a universe they were already standing in, then by every number we have gathered, that is us. We are the old ones. The first light in a structure that is almost entirely still to be built. Not comforting, exactly. The quiet around us stays exactly as quiet as it has been, and nothing here pretends otherwise. We may simply be too early for company, and we may live and die before the universe has anyone else to offer us. But we are here for the part almost no one will ever get to see. Still able to look out and find the afterglow of the beginning, still able to count the other galaxies before the dark carries them off one by one. The ones who come after us, 10 billion years from now, 100 billion, will look up into an emptier sky and never know how full it once was. So maybe being early is not only the loneliness, maybe it is also the one chance anyone ever gets to see the whole of it while it is still here to be seen. We came at the start. We are the ancient ones. The future will never get to meet